solved by Pythagoras, right? The plane is headed due north at 150. So all you do is just draw a sketch. That's 150. Wind of 35 blows towards the west. This way is west. 35. This feels like it's really zoomed in. Okay? So your picture should look like that. You don't need a scale because it's north and west. It's by Pythagoras. You don't need to change those numbers to a scale. You just write r squared is equal to 35 squared plus 150 squared. And then you find the square root. And is it 152.5? Is that right? 154? Yeah, that sounds right. I'm just going by with this one here in my hand. 154 kilometers per hour, right? And you need the angle. The angle is the one down here. There was one person, I think, that had their calculator in radians. You can't have that. Okay? There was a couple people that weren't sure how to use tag. You got to find out real soon. I guess that's what the pretest is designed to do. Find out if you know what you're doing before the test. 35 over 150. So you have to go second function tan. 35 divided by 150 equals 13. That sounds right. Good. So that's going to be north 13 west. North and west. Are you seeing what you did wrong? Yeah? 1 mark, 1 mark, 1 mark for the picture. Okay? Guaranteed. That question's on the test. It's different numbers. Guaranteed. Get better than what you got. If you got 3 out of 3, do the same thing. If you didn't get 3 out of 3, fix it. Make it right. Okay, the scale one, actually, most people did the best on that, which was a little surprising, but I guess I just done it that day, right? So we got a plane headed at west 30 south at 200. So west 30 south. So you draw your reference line. And you're going to go west. Ooh, that's not straight. You're going to go west 30 south. Like so. You need a scale. Remember the scale always, 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 never any other way. Always 1 centimeter equals. There is no other way to do it. That is the only way. 1 centimeter equals, and then you get your choice here. I got a 200 and I got a 50. A lot of people went with 20. And you have to write kilometers per hour. You can't just write kilometers, because that's not what it is. It's like me calling you by your brother's name. Don't want that. Right? It's kilometers per hour. And this is going to be 30 degrees in here, west 30, south, that's 30 degrees. And then from there, we're going north 15 west. So north, there's your reference line, and then we're going to go 15 west, and it says 50, so I'm going to go 2.5 centimeters. So like this, roughly. I'm going to get rid of that 30 degrees in there. And then your resultant is from there to there. Right? Okay? And generally, I don't really care what the number is, as long as it's close. About 195, is that right? What'd you guys get? Who had a mark right? 100%? 190. 190? I don't have my answer key in front of me here. So 190 kilometers an hour. And remember, where do you measure from? You're going to measure from this little guy right here, right? That reference line that we already did. You have to measure from east or west or south. How come I can't get it? Okay, so you're going to measure from that. Tia, what was your angle?
16 degrees.
Okay, so that's going to be west 16 south, right? You're measuring this little one right in there. Okay, I guarantee it. Adding by scale vectors will be on the test. 100% guarantee. Okay? Any questions? These 3 that just came in, I'll mark them right away. Those ones, you guys, I'll come by and I'll collect them later in the class because I usually record them just for my own purposes. Again, do these count? They count in that they teach you need to get paying attention or that you're on the right track, but they don't count towards your mark. Currently, everyone's mark is 0. Because we haven't had any assessments yet. Well, that's not true. I've done the lab at a time mark. Okay, but currently you have no marks, so don't worry about those. Get those in as fast as you can. Okay, let me close this and pause here and gather myself, and we're going to do vector subtraction today. Okay. Yeah, go quick. So let's talk vector subtraction. Okay, so after this, you're going to know how to subtract vectors, and even more important, how to recognize a vector subtraction question, because that is the classic grade 11 physics student question. How do I know when to subtract? I don't get it. I'm going to tell you. How do we add vectors again? What's the geometric, how do you place vectors so you add them? In the pirate thing, how do you do it? What's it called? Tip to tail, right? Okay, so everyone knows that. Tip to tail for adding vectors. How do you think vector subtraction goes? Maybe? Or tail to tail? Some other configuration, right? It feels like it should be. Okay, so addition means place them tip to tail, just like that, right? There's something here for me to click on. Now, let's sort of interpret this. Let's compare it to subtraction of regular numbers. About grade, when did you guys first doing subtraction, you think? Probably grade 1? Like you would have added first, I'm thinking, right? Maybe then subtracted. And you were probably taught right at the very start, when you subtract, you always got to have the big number first, right? Some teacher invariably told you that. Is that always true? No. They just don't want you to deal with negative numbers, right? That's why. Okay? So we're going to look at scalar subtraction. When did you start learning about integers and negative numbers? Grade 8? Was it that late, really? Okay. All right. Would you agree with me if I said that 10 minus 6 is the same thing as 10 plus minus 6? Is that the same thing? Right? Like before kindergarten, you could do 10 minus 6, and then you were introduced to negative numbers. It was like 10 plus a minus 6. Negative 6 is the negative of plus 6. So I've turned a subtraction question into addition question. Kind of magic. I've turned subtraction into addition, but to do that, I had to add the negative, or add the opposite. Would the same thinking be good for vectors, do you think? It kind of seems like it, doesn't it? And I am telling you that. I'm leading you down the path. Okay, so what then do you think, what is the negative, or what is the opposite? I'm supposed to probably click on something down here. No, it's not there. What do you think it means to make the negative of a vector? Or the opposite of a vector? How do I turn minus 6 into plus minus 6? Or how do I turn that into a negative? For a vector, what does it mean to have the opposite direction? I think I just gave it away without saying it. Let me. How do I turn a vector into its opposite? I change the direction. Pull a 180, they say. Okay? So the negative of a vector is a vector having the same magnitude, the same length, same size, but exactly the opposite direction. Exactly. So if vector A is to the east, then vector minus A is going to be to the west. Is that not easy? Can you do the opposite? Teenagers are usually pretty good at doing the opposite. What about if it's up and to the right as B? Minus B is going to be down and to the left. By the way, underneath this right here, there's going to be a couple questions, quicker ones, that you're going to do right away. See if you're watching. Okay, so like visually or pictorially or geometrically, going the opposite direction is pretty easy. But how do you do it when it's like a number? Like if I've got the bearing of 0, 1, 0. But the direction I'm headed is 10. What's the opposite of 10? 19?
170.
170.
180. 190.
190 is correct.
Just add 180.
You add 180, exactly. You pull the 180, right? Remember I said a few days ago I was talking about the runways, right? And I said the number at the end, and there's always two numbers, right? One is that direction, one is the other. Okay? So what would 300 be then if you add 180, Jason? Subtract 180. So the rule isn't always add 180. The rule is change it by plus or minus 180, right? If it's less than 180, you add it, and if it's more than 180, you subtract it. You could look at the full circle protractor. That's true. You could do that too. Does that make sense? Is there? What do you guys have? Is there any more there? Oh yeah, there's this one here. Let's stop and think about this one. If it's south 15 east, so south, I'm going to draw that one. South 15 east. Pull a 180. We're going to copy that one. Put it over here. You said west 15 north?
Or said north 15 west.
Yep. All you do is you just change that south to a west, and that east to a west, right? Sorry, south to north, east to west. The number stays the same, you just change those. That's actually pretty easy to do. And then what? We've just changed positive vectors into negative vectors. How did we subtract before? I'm going ahead of myself here, I know it. How did we do the regular one here? We added the opposite, right? So we figured out how to do the opposite vector. Now you just have to add it. That's all you do. But before we do that, let's do a quiz here. I'm going to challenge you right off the hop. So what is the negative of 10 meters per second east, or the opposite? It's just the direction that changed. Okay, so I throw that in there just as a little trick, but to sort of teach you something there. Okay, so 10 meters per second east, the opposite would be simply 10 meters per second west. You could say negative 10, but then you wouldn't have to include the west, right? The negative and the west are kind of both the same thing. Okay. Okay, what about this one? If vector x is 25 kilometers an hour at north 30 east, what is negative x? We got north 30 east. What's the opposite? Ladies at the back there, we're waiting on you. And the answer is, almost everyone got it. It is D. Right? So north 30 east, the north becomes south, the 30 becomes west. Right? You just swap them. South 30 west. If you got that wrong, make sure you try to figure out what you did. Okay, so here's the rule for adding or for subtracting vectors. Subtract vectors, find the inverse or find the opposite or find the negative of the vector to be subtracted and simply add it tip to tail to the other one. That's the rule for subtracting vectors. Well, hold on, Mr. Bennett. You said that this is going to be really hard. But have I made this hard? You take one, you swap the direction, and then you add it, which you can already do. What's so hard about it? And I have to agree with you, I don't know what's so hard about it. But kids always struggle with it. Okay? To subtract vectors, you find the inverse of the vector to be subtracted and add it tip to tail to the other one. Okay, so, for example, I've got A minus B. What do? You got to convert this A into negative A. So how do I do that? Pull a 180, swing it around. I just have to flip it left, right, and flip it. Yeah, come on. Click. Why can't I get it? Okay, I'll just do this. Oh, I did the wrong one, didn't I? How do I know I did the wrong one? I didn't mean to do that. Sometimes teachers make mistakes, but they work out good. What's wrong with this? If I do this, come on, I'm having trouble today. Is that minus A? Is that correct? It's not? Well, that's A. Is that not the opposite of it? I put it tip to tail. What did I do wrong? I didn't flip to B. Why do I have to flip to B, not the A? Because it says A minus B. The one you flip is the one you're subtracting. Okay? The one you flip is the one you're subtracting. So that is wrong. In fact, I think I have. Can't see it, no. Okay, so you're going to take that value of B and you're going to flip it upside down. Okay? You're going to turn it the opposite direction. You're going to make it negative. And then do what? Tip to tail. So I put this one where? Right there. Right? You add the opposite. So it's A, and then you add minus B. Does that not seem pretty straightforward? And yet, kids struggle. I don't know why. Well, I mean, they get more challenging, but that's kind of the basic idea. Where's the resultant from? From where you start to where you end. Okay? Now, I have to warn you ahead of time as well. Vectors is not just sort of a little weak unit that is part of this. Vectors are a fundamental part of physics. You use them pretty much everywhere. You're always adding, not always subtracting, but you add vectors almost in every single unit. Okay? So you do, it's a fundamental skill. I think I should do this one with you, right? Do you have this one as an example there? That's right at the bottom, right? If A is 10 meters north and B is 15 meters east, what is A minus B? Okay, so which one am I flipping? B. So negative B, let's write it right underneath. Negative B is going to become 15 meters west. And I just turned it into vector addition. That's it, like done. We're going to go north and then we're going to go west. We're going to go 10 north, and it's north and west, so we can use Pythagoras. I don't need a scale. So 10 north, 15 east. West, that's what I said. I went the right way, I said the wrong thing. And then resultant. As far as I know, you know how like in regular math you have the sum is what you get when you add, and you get the difference when you subtract? As far as I know, it's still called the result. Okay, so how am I going to do it? Well, you're going to write r squared equals 15 squared plus 10 squared. R equals, now I'm hoping you can do all that sort of in one step. Kind of done good, so. You should be able to go 15 squared plus 10 squared, of course, is 100, and then take the square root. $18. 18, I guess this is going to be meters, right? Find the angle where you start. Always, always where you start. Theta equals inverse tan. There was a couple people that had problems with this part the other day. Opposite the angle. 15 over 10. Okay? If you still haven't got it figured out in your calculator, please ask for help real soon. Second function tan. Bracket. 15 divided by 10, 56. How do you know what letters to put in front? Well, it's going to be from there. You're talking north and west, right? North and west. There's a lot of math in there. We've done a lot of different things. We did graphing. I did that whole rant about models, laws, and theories, right? We're going to start solving equations soon enough. Yeah. That's it. How many marks should this be worth, do you think? 4? Well, 1 for that, and 1 for basically drawing the picture and flipping it. So really just 3. I don't know where the 4th would be. Yeah. Okay, let's see what you know. Do you like the clickers? Are they good?
Yeah.
Tell me why.
Okay, fine.
Are they really?
Yeah. Thanks.
I'm glad you're enjoying them. Most kids like them. I like them because it makes kids pay attention. And you get to find out if you know what's going on right away, right? Yeah. Okay, I'll pause for a second there. How'd we do? Answer is C. Most people got it. C. A is north. B is west. So minus B would be east. C. Right? It's not hard stuff. Okay, now, here's the hardest part. How do I know when to subtract? Well, there are some where it's obvious because it will say A minus B. I spent time in this little animation, so you have to watch it. All right, there's A, there's B. Is it playing? Yeah, there it is. There, oh, it's going to make minus B, it looks like. It's going to flip it around, right? I must have been really slow this day. Holy moly. Oh, there's A. Can I do that? Notice that's tip to tip, right? Some textbooks will actually claim that you should do it tip to tip. I don't like that way. Right? Do it like that. Okay? Flip it around. I like it like that. Okay, so you will notice subtract because of that. Now here's the key one here. Okay, now I haven't really talked about too much about this. We've got a little bit where there's like a plane and wind. Have I talked about planes and winds? Just very, very briefly. I haven't made a big deal of that. So here's where I'm going to make a big deal of it. Okay? So, it implies subtraction. What does imply mean? Like to suggest. It suggests subtraction, or it makes you have to think on your own subtraction. Because it asks for the wind or the plane speed, or the current or the boat speed. The two classic physics cases are plane in the wind, boat in the current, boat on a river. Okay, so they're going to be those two situations. So what I'm saying is this. If you've got a plane in the wind, the resultant is the plane plus the wind. Remember a few days ago I showed you like there were planes that were coming down the stream and the wind was blowing it sideways. Do you remember that?
Yeah.
Right? Okay, so the resultant is, if the plane is going south and the wind is going east, where is it going to end up going? Southeast, like that, right? That's the resultant. Do pilots need to know that? Absolutely. They get up there in the jet, right? The wind's going this way. They got to, account for the wind. Otherwise, they end up in the wrong spot. And they only carry a little bit of extra fuel. Okay. So, if you've got, and these are all vectors, I should clarify that. Those are all vectors. If I ask you for the plane or the wind speed, how would you find it? If all you had was this, if I said 10 is equal to x minus 4, well, let's say x plus 4, make it a little simpler. If I said 10 is equal to x plus 4, how do you solve for x? Take the x to take the plus 4 to the other side and it becomes? No, 10 minus 4, right? You subtract. So if I'm looking for the wind or the plane speed, what is the plane vector equal to? If I need to get the p all by itself, the wind has to go to the other side, it becomes r minus w. Right? If I've got plus w here, it has to go to the other side. The plane speed is the resultant minus the wind, and those are vectors. And likewise, the wind speed is going to be resultant minus plane. Vector subtraction. Okay, but it's not going to come out in, flashing lights, horn, subtraction. It's not going to do that. It's going to say, what is the wind speed or what is the plane speed? Okay? The same is true for boats and rivers. The resultant is the boat plus the current. All vectors. What's going to be next under the little screen here? What am I going to ask you for? You probably have on your page. I'm going to ask you for the boat and the current. So what's the boat? What's the vector formula here for boats? Resultant minus current. Well done, Jason. Resultant minus current. And the current is going to be resultant minus boat. Okay, so you got 35 meters per second north. And then 10 is 10 meters per second east, but negative 10 is going to be 10 meters per second. This feels like the one I did already. Is it the same numbers?
No.
Okay, good. Because that'd be so. It's the same angle, yeah. Right. So 35 and 10, right? R squared is 10 squared plus 35 squared.
Square root over 325.
Okay. Not enough light here. What is it?
36.5.
That seems about right. 36.5, that's going to be meters per second. Theta is equal to tan minus 1. Opposite is 10. Adjacent is 35. I got to stand over here where there's more light. 16?
15.5.
16. So that's going to be north 16 west, right? Is this hard? Not overly. But I am telling you exactly what to do, right? So, but you got to be able to start figuring that out on your own. Okay, let's try this one. This one is harder. There's no doubt about that. This one's a step up. I'll give you 5 minutes. A plane needs to end up with a resultant velocity of 100 kilometers an hour at east 30 north. Okay, so let's say it's got to go east 30 north. East 30 north. So it's going from I don't know, I'm trying to figure out a place that's Toronto to Ottawa would be about east 30 north, right? There's Toronto, there's Ottawa. You got to go east 30 degrees north, right? And you got to go at 100 kilometers an hour because you got to be there in 2 hours. That's 200 kilometers away. I don't know. That's the resultant velocity that you need. The wind speed is 25 kilometers an hour at north 15 west. What direction and speed should the plane take? So we are asking for the plane's direction and speed. We're asking for the plane's velocity. Vector. So I would suggest you start with resultant is equal to plane plus wind. Write that down. Right? Get your thinking straight. Resultant is plane plus wind. And if I need to know the direction and speed that the plane takes, then I'm going to write plane is going to be equal to resultant minus wind. Okay? And that little process helps your sort of thinking. Right? The plane vector is the resultant vector minus the wind vector. So I got to take the resultant and I'm going to add what? Negative wind. Plane is equal to resultant plus minus wind. Now, you don't have to write all those steps down, but it helps you figure it out. It gives you the steps. So now I've just turned it into vector addition. You only have to just do that swap thing. Okay, so the resultant velocity is 100 at east 30 north. So east 30 north is to the right and up. So I'm going to draw a little reference line. oh, I need myself a scale, don't I? How come I have to do this by scale drawing? Because it's not a right triangle. So I need a scale, like 1 centimeter equals something. I need 100, I need 25. Put 10, okay? 10 kilometers per hour. You can, Skylar. So I'm going to go, resultant is 100 at east 30 north. So I got to go east 30 north. Now I'm just going to roughly do it, just to save a little time. So east 30 north, and I got to go 10 centimeters, right? So kind of like about like that, right? Yeah? Give me the nod of understanding. Helps me to, otherwise I got to go back and redo it. That's the result. And now minus wind. So now the wind is 25 kilometers an hour at north 15 west. So that means that minus wind is going to be what? Not north 15 west, but south 15 east. Right, Alexis? South 15 east. So south from there, and then 15 east. And it's only going to be 2.5, so just tiny. Does it go past 0? Has anyone done this yet? I don't know how far to go, because I'm not measuring. Is that about right? Roughly? Otherwise I have to get a ruler. Okay, and then your answer, so this one is the resultant. This one is resultant. This one here is minus wind. You should label it. It really helps me when I'm marking. Just follow your thinking when you label. And so this one here is going to be the plane. So from there to there. That's the plane speed. Is that close to what you had? Yeah? And then how do you find that plane speed? How do you actually find it? You get out your ruler and you measure it, and you get out your protractor and you measure it. Are we good? I'm almost run out of time here. You guys have been pretty attentive today. It's been pretty good. It's been a long period. Lots of thinking. I think I got nothing left, right? What do you got left? Practice. Okay, so normally this takes a full lesson, a full class to me sort of explain, and then a full day of you working it out kind of thing. Okay? So what I'm going to suggest you do is, there's extra practice here. It wouldn't hurt you to try one of these today. I'm going to give you some time tomorrow. I'm going to take in those quiz. If you handed in your quiz yesterday and I marked it, I'm going to come out and grab it now. I want to record it. I've got to talk a little bit more about extra subtraction tomorrow, to sort of clarify things. Then I'm going to give you some time to work. You can put the clickers back. But basically, that's the unit. Yeah.